Big fun items on the to-do list. If you don't mind me making a list pun, I'm actually going to move my to-do list over here. Do I have a pen handy? Oh, I do. It's on the floor, though. Alright, come here, come here. There we go. Alright. So, what are we working on today? Well, let me demo for you the current state of 4coder. As of last stream, we had mostly figured out how to implement the buffer list stuff, except that I needed a few features from the core to actually support it. I'll show you that real quick. So, for instance, in order to set this up correctly, I wanted to be able to control the scrolling from a command. So we have this wheel scroll thing that gets the mouse state and reads the wheel value and then updates the scroll of the view. And then the reason we need to control it from here is whenever we update the scroll, we need to redraw the UI. Alright, we need to re-update the layout of the UI because where we are in the scroll can actually affect which things we bother to put on the screen, for instance. There's that one. There's one other one I wanted to show you before I actually get to it. There's this repaint one, which basically says, hey, maybe there was an animation happening that the scroll was smooth scrolling still, or the mouse has moved. Different things can happen that cause the UI to want to update its layout that are basically not changing the state at all, just redo the layout and that's it. So we have this repaint one, and the events that would trigger this also weren't exposed in the API anywhere. So if we look at list mode wheel scroll, it can now be bound to the key mouse wheel. So there's now an event for mouse wheels you could which get documented in the next build, but basically you can now get an event kind of like a key mouse left or any other key really that is an event notifying you that the mouse wheel has just been used, and you get that through your command maps like everything else right now. And then there's a mouse move event, so you can say, hey, I subscribe to being notified whenever the mouse moves. 4coder already does a full update whenever the mouse moves, so you're not making your program less efficient unless you do some really intense stuff in the mouse move part. Now, for instance, this means that if you're moving your mouse around a lot and you have a UI up here, that you're going to end up doing a lot of work, and we're probably going to want to do some optimizations to prevent ourselves from doing tons and tons of redundant work every frame that all that's happening is moving a mouse, because the repaint is actually a somewhat heavy operation right now that could be made lighter. Another one is an animate event. Whenever you go through a frame where you're animating, you get one animate event now that says, hey, no, like it doesn't say this like the user did something, but we just did a frame that was triggered by the fact that we were animating. So you might want to respond to that for some reason, and in this case we want to repaint the UI in case the animation causes the mouse hover to change, or if it causes the set of things on screen to change. So that also gets linked up with the repaint. So I got all of these new events working off screen, and now I can demo to you the buffer list stuff fully working. Let me zoom this in again. Okay, so I can pull it up, move it around, I can click over here and you can see I don't lose it, and I can pull up a separate one with a separate state, type scratch here and message here. You can see that they're kind of messing each other up, so one thing we probably want to do is figure out what's happening there, because this is clearly wrong. But I'm not sure why yet. So before we get into anything else, we do need to track down that bug. I saw that bug while I was working on it, but I wanted to save it for on-stream because it seemed interesting. We can also call load project, and that'll pull that up, and now I can do a buffer switch list that looks like this. I can click on a thing, and there we got the generate parser thing. There's also, we can move around with arrow keys, we can type stuff in and narrow down the list. all the goodies. We don't have wildcarding yet, I guess. So that's another thing that we want to get in there when we do this upgrade to the generic version of the lister API for the built-in lists, right? But yeah, so most of this is back to feature parity for this list. We just need to get the side-by-side working, and then I will do the wildcarding as we go for generic, because I want to build the wildcarding. I want to build the wildcarding in for everything generically anyways, so I'd rather wait until we've, I don't like to put something in a specific layer when the very next thing I'm about to do is to make that thing generic. I'm basically just doing the same thing twice at that point. If I don't know how to make it generic, I'll gladly do the easier one first, but in this case I think I know how it will become generic. It'll be quite straightforward, I think, so I'm not going to jump into it right out of the bat, doing it the specific way. So, yeah, let's get that bug figured out first. Let's see, bug. Alright, here's where text space, somewhere in here I submit that. Okay, why does that get messed up? I don't really understand why this becomes messed up, because I'm supposed to be, clearing all of it right away anyway. So there's not any pointers to the switch string being held, are there? There shouldn't be, right? Like, it looks like what's happening when I see the bug is that the thing that says switch on one of them gets corrupted right away, and then I'm confused by that because they're in different views, which means when I set view set UI, I'm supposed to make a full internal copy of the entire data structure so that that can't happen. Okay, well, I'd like to start by just walking through view set UI and see if any clues show up in there, because I'm suspicious. Okay. Yeah. Alright, let me zoom in here. Okay. 3 items. Memory size 264 bytes. Is the UI item that big already? Maybe I don't want it to be 88 bytes and I should shrink it down. I think I could shrink it down by a little bit, at least, to make it a little bit tighter. We allocate the 264 bytes in my memory heap, and then we memcopy. Uh-oh. Literally that's all I did? Yeah, that won't work. Wow. Okay. That's just totally wrong. Oops, 2249. Alright, so the problem here is I'm just copying these items into here, but those items have pointers. I have to do a deeper copy than that, right? A UI item has query string status. So let's make our lives a little bit easier here. We're going to rewrite this to have I think a union between these two. And the reason I do a union between those is I'm pretty sure that I never use both of them. Right? Query and string, and then up here I have string and status. Right? So, yeah, it's like not not necessary to have 3 strings built into this struct. 2 is enough. So just to keep the names the way they are, I guess I'll do it this way. But the rest of this all actually applies to everything. So we really just reduced that by, what, 16 bytes? That's probably the only easy reduction in byte size I can do. Now I could get a little bit more aggressive than that because I don't really need string size, length, and capacity. Really what I need is 2 pointers and 2 integers, so I could save 8 more bytes. Plus, if I reorganize this a little bit, there's well, this is 8-byte aligned, that's 4-byte aligned. So 4, 8, 16, 16, 8, 4, 4, 4, 4, 4, 4. No matter what I do, it doesn't actually help because there's not an odd number of 4s hanging out. There's like a total odd number of 4s, right? Between this and this, somewhere one of the 4-byte things gets padded out to 8. Hey, we have Flying Solomon! Welcome to the stream. Yeah, so I can't make this any smaller by doing packing stuff. Even if I spread these out into pointers and byte and to size integer things, I would still have an odd number total of 4-byte things, which would mean one of them gets padded out to 8. I guess the coordinate systems and activation level could actually both drop down to 16 bytes, and then that would let me save the 8 bytes. Right? I actually don't need all that. Which means if I group those together and I put them right here underneath the type. Now this is 4 bytes and this is 2 and 2, which is a total of 8, and those now group together, and then there's 2 8s there, 2 8s there, so we're still aligned to 8, 8, and then 4 4s there, so all the way through now we're 8-byte aligned, which means we have no padding. So that actually makes us smaller in a way that we can stand to, we can bear to lose that 16 bits there and there, because there's just never going to be that many combinations of, like, there's never going to be more than 6,000 or 60,000 coordinate systems or 60,000 activation levels, right? In fact, you could almost go ahead and say that those could both be 8 bytes, but I wouldn't really be able to take advantage of that right now. It would give me just 2 extra bytes of padding here, not 2 extra bytes of savings, right? It would mean that in the future, if I came up with more 8-bit fields, that I had space for them. So I might actually do that, though. Also, how many item types do I honestly suspect I'll have? If I do that, now I'm talking about 32 bytes here. I'm back to having a 32-byte thing, or a 32-bit value just packed right there, 1688. And then everything else here, right now I have an odd number of 32-bit things again. So I have 32 bits of padding that I haven't actually saved, but I have 32 bits of space that I can fill if I ever want to. Alright, so that's nice. Okay. And now getting back to the more pressing matter, when we do this copy, it's not good enough to just mem copy the items. We also need to find out the size of the string portion. Um, Alright, so that gives me an iteration across all of the items of the the input UI control. And for each of them, what I'm going to do is I'm going to look at their I'm going to look at their two strings, and we're going to add their lengths into this. So query dot size and string size, and then we get that whole loop done. That isn't going to be a problem, I hope, but if we need to, we can have the UI control build up its count as we add items to it as an optimization. Hey Jim, welcome to the stream. So yeah, so that gives me the size of the string portion. So I'm going to add that in here, and so there's our items. And then I want to do like text or string space. String space will equal the portion after the items control count casted to a character pointer. So we take the items, we advance the pointer all the way past the space that we need for each item, and then we get the string space. And then we can do that right there. Now, when we do that copy there, we can now go ahead and say, give me the count memory size. So there's item size, item total size, or all items size, all items size. Alright, so now we're copying that, and now we just need to go and fix up these strings here, which will be incorrect, right? So we need to do for the entirety of that, we're going to have actually, we can just do this the clever way again. Item is now going to equal this guy's item. Ugh, it's such a long name though. Why don't I do it this way? Name that the new items. And here we'll do that, and we can now do this. And so if that all worked, then we get the string space. We're going to set the items, the count, do the mem copy into the new items. Right there. And now I can just say new items, and then one past last will equal the new items plus the count. And then as long as that's less than that, we can keep iterating one at a time. And for each of these, what we're going to do is we're going to say, basically what we need is a new arena on the string space, right? And so that way what we can do is at each step I take the old I'm going to make an array of strings to change, fix up, fix up 0 will equal the item's query. These need to be pointers. And fix up 1 can be its string, and then we can do a little fix up. There we go. And then we do fix up I old. We grab a copy of fix up I, and then we say that fix up I equals string copy, or push string copy onto the string allocator, and we copy the old string, right? So that way we're grabbing this that has the pointer in to the wrong place, and we push a copy onto this. Now what we are going to want to do is do a +1 here and here, because that's going to store null terminators too when it does the string copy stuff, and then it'll have all those things fixed up, and that should fix our bug. Let's see if it builds though. Right, you need a deref here. String, is this in like helpers? Push string copy. Ah, shit. Okay. Let's, well, does my string, oh, that's why. Ugh. The 4coder code base is such a mess. It's a mess because I tried to build it out of like single file headers that like single file header libraries that I wrote myself, and the problem with that is I also really like to be able to interoperate. I find that, like, for instance, being able to use my arenas everywhere is a plus, but my string library was written with the assumption that I didn't want to depend on anything else, and so now it's a mess. If I had just gone ahead and ignored the idea of a single header library, I could have gotten all my things to interoperate tightly the way I like them to. But I didn't. So we're going to have to do a little bit of work to do this. New string equals push an array onto the string allocator, bold.size. I guess, do I want null terminators or not? I actually probably don't. So given the option now, I won't take the null terminator. Push that there. Fix up I string equals new string. Fix up I size equals old size, and cap equals max, or memory size, that's what it's called. Memory size equals the old size, and then I just have to mem copy into the new string from the old string that much. Okay. Flying Solomon says he appreciates my single header string library, which is good news. I didn't think anyone even like comprehended how my string library works, because it's so like bonkers. But if you get it and you're using it, then that makes me very happy. That's the first I've ever heard of anyone using it. So thanks. I don't know, man. There's stuff like this, like wanting to be able to push a copy of a string onto an arena, that I just really wish I could find a way to do. In a better language, it would be no problem. I wouldn't have to worry about this shit, because what I would have is some kind of thing that's like if interoperate arena, and then boom, right? Like include this code, right? Something like this. But I don't really know any language that goes ahead and gives me that much flexibility. So, not sure what I would do. I mean, I could make that work with macros. I could like make a whole meta-programming shit show that generates that shit with macros, and then I could include right here like an if interoperate arena end if, or something like this, right? So maybe I wouldn't even need to metaprogram it, but I don't like the fact that it looks like this, so what I would do is I would metaprogram it. I would have it look more like this. It might be like at if interoperate brace brace. And the reason I would do that is because I much prefer the look of the code, although I would have to tell my indenter to be smarter because it doesn't know that these indent at the same level. But then what would happen is the parser would see this and turn it into preprocessor code. If interoperate arena, and then yeah, I know you can achieve it with if defs. It just makes the code really hard to write. In fact, even what I was just suggesting wouldn't make it any easier. It would still have all the same pains in the ass because it not only matters when you do that, it then matters what order like headers get included in. So another thing I don't like about single header libraries is that you have to make it work as a header and a CPP file. I've found that if I can do types and then procedures separately, that makes life very easy because then any procedure from that, like if I have my arena struct existing before I include my string.cpp, that just makes life easier. If I have to do like include this header and then this header and then this header again with the implementation and then this header with the implementation in this order, it's a big pain in the ass. But maybe I should think about a way to like split my, I don't know, split my library into, if I could auto-detect what parts are self-contained and what parts aren't, or if I baked my arenas right into the string library and made it just Allen's like string memory and I don't know, is there anything else that couples in with that really tightly? Maybe not. Then I could just make a single header out of all of that shit. Which is honestly not that bad an idea. I should make a single header that's like all the code I always write for every project. That's like my type defs, my arena, and my string. But then it would be less useful for people who want to do their own type defs and stuff. I don't know. Anyway, I don't know. I've said that a lot, so I don't know, but I'll stop saying I don't know. Okay. So I think that this works, but we need to test it. So I do that. Don't want to walk through that. Uh-oh. Crash and burn. Uh-oh. String space. Uh-oh. Items. Uh-oh. Ah, that should say new items. Okay. 2257. And I totally appreciate how awesome a single header library is when you're the user of the library and all you want to do is drop it in and start using it. It's just much more frustrating when it's a part of the ecosystem that you're trying to compose into a code base. Like, I don't know, I always find that single headers are like a stepping stone into me integrating something more fully into the way my stuff works, rather than them being things that I keep around forever. They're like stepping stone libraries, and how you transition from a single header library to a integrated library that fits in with everything else you have, I don't know. I haven't studied it enough. So I can do this here, and this here, and they're completely independent now. So that's nice. It's kind of, there's often like a sort of donor slash receiver compatibility trade-off thing. It's like blood types, right? Libraries are like blood types. You have certain ways that you can create a library that make them very easy to use for the receiver of the library, much like an O negative blood type can be received by anyone. But if you yourself are the one with O negative blood, then you're screwed because there's no one's blood you can receive but other O negative blood. Whereas if you have the opposite blood type on the other end of the spectrum, AB positive blood, the only people who can ever accept your blood are other AB positive people. No one, your blood is almost useless for saving anybody, except that you can easily be saved because you can receive anyone's blood. So there's like the universal receiver and the universal donor type thing. And an STB library is the universal donor. But if you want to build your entire system out of that, you also have to be like, you're not necessarily set up in a way where writing your code that way is good for your project internally. It's just good for the people who will receive the library you send it out to. So there's like, I don't know. In a certain sense, I think that a single header library shouldn't be something you build as part of a project. Rather, it should be a thing you set out to build as a project of its own, because it doesn't make for a very great like receiver, right? You don't want your project built out of that shit because it isn't a great receiver for new things. It's only a good donor to other things at that point. Okay, so we fixed the main bug. Now what we want to do is start figuring out how to abstract these things for other types of lists. So the first major obvious list that we can do is the open a file list. So let's focus on that one, because everything will basically fall into one of the two patterns, either the buffer list or the file list at this point. So let me go to the lists code. So a quick, let me do a quick Alright, so we have the ability to allocate a list state for each view. We have the ability to fill the UI with the buffer list. This we need to really generalize. This is the core of the system that is not generalized yet. This right here would actually always be separated because each list has a different activation method that it wants to call upon activation. So the fact that that's separated is actually okay. We just need a way to specify how to activate the list when we create it, which we don't have right now. Right now that's just baked in, so we need like a callback that points us to that to make it an indirect call to this. Get clicked item. So this is just a helper. Let me bounce it up a little higher because this works as written already. With this you just pass it the basically current view and an arena that it can do some work inside, and it will get a copy of the UI from the view, search it for the item, and return a copy of that item to you. Right, this is a super piggy solution that uses mostly wastes cycles because it has to do this copy back thing. And you know what, in the process yeah, I bet it does the same nonsense that this was doing of just copying and not actually fixing up its pointers. Which we should probably not leave in. But it's not a priority right now because at least those pointers will remain valid for this purpose. Yeah, at some point I'd actually like to eliminate this and say that you need to figure out how to keep the copy yourself before you submit it, because having this is just super piggy because we're setting and getting such a large data structure in like bulk there that I'm not happy with having that around as an option, you know? But anyway, let's keep looking through all of this. So we can then we have these things here. So activate, for instance, directly calls stuff that is somewhat specific to this particular list, I think. It's iterating the buffers. It's figuring out which buffer is actually selected. Right. So this here is not generalized, but it won't need to exist in the generalized version, because the generalized version will do a better job of keeping track of what the currently selected item is, so that when we activate, it doesn't have to deduce the active item and then pass to activate switch buffer. Right. This will be a part of the thing that gets not even callbacked, but just solved by the general solver instead of having to be specifically solved on a case-by-case basis. Yeah, so that one just works. Yeah, that'll just work. Move up. That'll just work. That'll just work. That'll just work. That'll just work. So actually this hop buffer ID won't quite work, but that'll just get fixed in the generalization pretty much for free. Yeah, that'll get fixed, and the repaint will work when we can when we generalize this into when we turn this into an like a data structure driven list thing. Okay, so the primary thing I think, looking at all of this, is this part right here is wrong. So how do we want to go about creating the new version? Let's start by imagining an API that would let me write both this and the lister I need for files, right? How would that look? Well, I mean, the really easy lister API was originally going to look like this, the really easy to use one. Instead of having all that, it would just go static void generate switch buffer list, right? And I don't know what parameters that would take yet. It would probably have to at least take an application link and probably a partition, and I think that would be it. At least on the case of the switch buffer list, that would be it. And then what it would do is it would do this buffer iteration right here. So we're iterating all of the buffers, and we are saying for each buffer, get the buffer name. Let's see, what else do we use out of the buffer? We use the buffer name. We use whether or not the buffer is dirty, and its ID. Okay. So let me just grab all of those. I should stop doing that and start doing what I normally do, which is pull up my docs. Okay. Dirty state. And then there's buffer ID. Alright, so those are the three things I actually need. And then, sorry, my nose is itchy now. I'm not sure why. Ugh. Okay, and I need to it's going to be something like lister add item lister. We're going to provide buffer name. For the dirty flag, what we'll do is this, and we'll say yeah, so we have to be a little careful here. We want to do well, yeah, this okay, I see it. So we're going to do a sort of status thing here. So there's the empty one, whoops, stay full size. There's the unloaded changes and unsaved changes versions. So this one will be like that, and this one will be like that. Status, and then buffer ID, right? That's all I need to specify to the lister. The name, a status string, and a user data that I can get back from it. All of the stuff about its rectangle, its activation level, its coordinate system, its item type, that I don't need to think about when I'm just saying make me a list, because by saying make me a list, I've implied the values for all of those fields. So by saying make me a list, the only a bunch of these fields get implicitly deduced, and the only thing that isn't deduced is name for the buffer, the status, and the user ID. So those are the things I still have to set. So that makes a very nice tight API right there where I get to list everything from the buffers. And then we can do a sort of why is that called a UI list? That's going to be confusing. Oh well, I'm going to just call this a lister equals lister begin, and I just pass in the arena there so that these strings can get pushed onto the arena as I'm going. Yep, so we will push all that on to the arena, and then at the end we're just going to actually return that lister and use it somewhere else. Right? So that's how we get the lister for the buffer. That's it. That's the whole thing. And let's see if we can write a similar one for a file iteration type thing. Generate file open, generate buffer list, generate all buffers list, generate hot directory file list, partition arena. Alright. So that'll start the same way exactly. And then we're going to want to look at directory get hot. There we go. Yep. Right, okay. So horrible string APIs that were inspired by Microsoft back when I didn't know how to handle things. See, nowadays, let me give you a tip. This is why I like to couple my string API with my Arena API as tightly as possible. The easy way to write something like this is to go boom, boom, right? And so now what happens is if there's enough memory in the Arena, you get a string. If there's not, you don't. Period. If you wanted to get a little fancy, you could add in a thing right here that also returns capacity to you as an optional return if you want to be able to ask something like, hey, give me a string, and if you fail, tell me what capacity you needed, and I'll allocate a new arena so that you can give it to me correctly, right? And that's like it. That's everything you actually need. And most of the time, you would just call it like this and be happy to usually get your thing here because your arena is so fucking big you never run out of memory, right? But that's not how any of this is written in the current version because I didn't know what I was doing, because I was a little fledgling, only getting started figuring out how the world works. So now I have to do this nonsense. Actual size equals this. Let's start with char star hot directory int32 actual size. Set them both to 0. Okay, so now what I can do is I can go boom, boom, whoops, boom, boom, boom. Oh, okay, I see what I can do. Alright, so 0, 0. Don't write me anything, give me the actual size. And then hot directory can be push an array onto my arena of the actual size. And if that is not 0, then we can go ahead and read it. Okay, that's about as good as I think we can make it. There we go. That should work. And now I have my hot directory, so the next question is, how do I get a file list? Great. So this API here is convenient because it does the allocation, but it's inconvenient because it doesn't take an arena, which means it also has to have a paired API for doing the deallocation. The nice thing about passing arenas into calls is now that call can do an allocation for you rather than making you do the allocation, but it makes it very easy for you to do the deallocation by simply clearing the arena later. Which I didn't understand, and now look at what I have to do. Alright, hot directory, actual size, and then later I have to call this again. Wait, I have to call free file list, that's what I have to do. Because now this thing is the one maintaining the memory, which means it also has to be notified when to free it, etc., etc. So we get file list, free file list, good, and then there's the actual matter of iterating the file list. Infos count, 4. File info equals file list dot infos 1 past last equals file list dot infos plus file list count. Info is less than 1 past last info plus equals 1. There we go, an iteration across the info structs. Now take me to a file info. Hey, the link worked. Okay. So, each of these has a file name, length, and whether or not it's a folder. Cool. So what I want to do is, for each of these, we're going to say lister add item pre-alloct, which will be very similar to the thing up here, except it's going to look, it's going to let me pre-allocate these names on the arena. See, that fucking sucks. I don't want to have to always pre-alloc manually, but sometimes I am going to have to anyway, and so then in that case I would like to be able to say, hey, this one's pre-alloc, but not have to say that, oh, I wanted to pre-alloc both of them, because I don't necessarily want to pre-alloc both of them. Although I probably do in this case. So what do I do? I mean, the obvious thing is that you just have like a pre-alloced lister pre-alloced thing here that is just a pseudo constructor that you can put around like that whenever something is already pre-allocated, and that just will take the string and stuff it into a different struct, and then an overloaded function would figure out what to do. I would return an empty list in that case. So if the question is, if I passed an arena into here, get file list, and there wasn't enough memory, I would return an empty list with no changes to the arena, and then you would know that your arena wasn't big enough. If you wanted to query how big does my arena need to be so you can allocate a new one so that you can make it more robust, then what you would do is I would simply add a like parameter here that's like get capacity, and that would be an optional parameter that you could pass so that if the first time it fails you can get it again. And then the other thing you can do is say make something on top of your base arena. So my base arena is just don't do anything fancy, but you can make a thing on top of your base arena that's like, if an allocation fails, then go to the system and grow this arena then, and that way, and attach it to the arena. So the new memory gets allocated at the system level, but it's attached onto this arena too, so now your arena is a segmented arena, and when it runs out of memory, it just goes to the system and gets more, and is still a part of that arena, so that you're still managing memory all with that one structure. And once in a while I go that far. Usually it's not necessary, but it can be done. So the difference between a not enough memory and a no files to return would be something you'd wanted to think about how you're going to specify that. So often what I end up doing is my like file list, if I was using that API, would have like in here somewhere would have like success, so that you always just check this to see if you have run out of memory or not. Or it can be like right, something like this, or alternatively you can put the error code here, right, something like this, so that you have some way to check if there's no way from just the return value to determine if it was what kind of failure you are getting. Is it like a out of memory failure or a no files available failure? Then that just means you need a new way to specify that information in the return somehow. And so you would just extend your output channel a little bit. Like one thing I often do is for an empty, I will return a pointer and a count of 0. So like I actually will still make this pointer non-zero by saying I tried to allocate, and so I have a pointer to when you have an arena allocator, you can ask for an allocation of size 0 and have it give you a pointer to where it would have allocated, where basically every time you call a push on your arena, it would always return the same thing no matter how big you ask for. If you ask for 10 bytes, 1,000 bytes, or 0 bytes, the pointer you get isn't changed by that. It's the next pointers that are affected by your size, which means you can say push 0 bytes onto the arena, get the pointer back and stuff it here, and then set 0 here. That'd be a very easy way to indicate that, hey, since info's is not equal to 0, um, I can deduce that it did in fact successfully complete and try to give me a list, and there just were 0 options. Whereas if info is equal to 0, that's an allocation failure situation. I guess I should change what I said. The only time the size affects what gets returned to you in an arena should be if there's not enough memory to allocate what you needed. Because if there's not enough memory, then it should either return 0 or it should make a new chunk and then return the beginning of the new chunk, depending on what kind of arena you're thinking about making. Probably the smart thing to do would be to make auto-growing arenas the default and pass those around everywhere. I never do that because I have some other tricks that I do with arenas that that break if you use auto-grow. But probably what I should do is, for those cases where I'm using that trick, jump down to my low-level arena that doesn't auto-grow, and generally always let my arenas have access to the system layer so that they can auto-grow, and I would just never have to think about memory again at that point. Probably. Anyway, we're iterating these files. We're going to get a file name, a status string, and then we need some kind of user data. In this case, my user data is going to be the file name again. And then what we'll do is we'll say, let's get those. So file name okay, so that gives me a copy of that. And then what I want to do is I want to say, actually, I want to do something a little bit different. Do I have a build-in arena type thing? These let me compose strings. That could be good enough for now. Yeah, the BMXer says, I sometimes use virtual-alloc with a huge size reserve and only commit more when I need it. Yeah, that's a good technique. I find that I generally don't have just a few monolithic arenas, but rather a sort of large selection of arenas, so that ends up leading to some of the more classical heap management problems that you get. If you have like one big arena, you can just keep growing that one by committing on the end of what you already have. If you end up with 20 arenas, then you can only do that when you're not going to start overlapping an existing arena somewhere else, right? So my growing arenas are a little bit more complicated than just commit the next thing in a line, which would be very ideal. Although I could probably stand to like make mega arenas that are like, hey, this one is likely to grow very big, but I don't want to start with it very big, so let's start with it small and have it reserve a lot of space, but not necessarily need it right away. But if it has to become a gigabyte, we reserved that. Yeah, you're right. With 16 terabytes of address space, you can pretty much just say, look, everyone gets a gigabyte of reserved space, and you're never going to run out of gigabytes to reserve anyway. I basically just resigned to I have a separate arena, not in the 4coder code base, by the way. The 4coder code base isn't this sophisticated, which is one of the things I've been complaining about. But in my more recent code, I basically just end up having an arena per life cycle, basically, or per memory management life cycle. So, like, there's this bit of code I wrote that ends up having 4 arenas all at the same scope because they clear on different schedules. And so I just, I went with it. it turned out that 4 stacks was the efficient way to implement that code, I think. Okay, so point is, I don't quite like this. I don't have a build-in partition type call that I would like to have, as far as I can tell, which is another failure of this code base. But I do have a build string, which will be good enough for this case. So the way build string works is it makes a copy of a concatenation of several strings without you having to do anything. And the reason I want that is because I want to be able to do this. So I don't need all 3, I just need the first 2. And then trailing will default to this, but if the info is a folder, then the trailing will become a slash, right? Because in my lister here, folders get a slash to indicate that they're a folder, right? So now I'm setting my file name that I'm displaying like that, and that's good. And that gets pushed onto the arena, and perfect. Now for the status, if I look here, yeah, I put loaded if it's loaded and a star or an exclamation point as well. Alright, so that is interesting. Maybe I do want to pre-alloc both in this case. So there's my file name. My status is going to look like build string arena, and then we're just going to have is loaded status and nothing, right? And then to get those, we have is loaded equals empty string. How do I figure out if a file is loaded? Oof. So that's a little bit gross. I'm going to come back to that in a minute. Because figuring those two things out is a bit complicated. Yeah, strings a struct. It contains in it it's basically a char star with a size and capacity attached. Basically think of it as a glorified char star though, right? It's just another pointer. It's just a pointer that is coupled up with its size so that I can make calls that return them all together all over the place. Alright, so the next problem is figuring out how we're going to do that part, I think. Well, I don't know. Do I want to focus on that or getting this lister API part working? So here's the problem. If I implement this now, it could take me down a path that'll take a little while, and it's going to get kind of sprawling and distracting from the API that I'm trying to write. On the other hand, if I just write the API right now, there's a chance that I won't come back to this today, and then when I do have to come back to it, it's going to feel like a chore. I feel like I should do this first, because it's not going to be so distracting that I can't do this, and the thing won't build until I've written this anyway, so that I'm forced to do. This I'm not forced to do, so we're doing this first. Alright. Now to figure out how we're going to do this, what I really would like to do is look at my old code. So I'm going to pull up Bitbucket on my hidden screen over here, and I will be looking through some code from old commits and stuff off screen for just a minute. So bear with me. Let's see. Do. All right. Okay, so now I'm looking for the file list. vui none. There's vui none. Where are the others? Theme. Interactive. Interactive. Sys file list. Okay. Alright. I'm hiding this because I don't want Bitbucket details being public, by the way. How do I do what? How do I get the is loaded information and the status information? I'm going to find out. I have it written here, and I want to get as close to simulating its behavior as I can. So when I do the listing, begin scrollable, GUI standard list. Excuse me. I take the full path to the file, which we can pretty much achieve, I think. I check if I match that, and then I said, does the working set contain this? So that's the tricky part. How do I simulate working set contains, which is an internal API from here? Let me look through the API implementation and look for something that calls working set contains canon. Okay, I think create buffer is what I actually need. Oh, here's another one. Ooh, this is better. Get buffer by file name. So this will get canonicalize the name, and then see if the working set contains a file with that canonical name, and then it will fill buffer summary and return it to me. Perfect. Okay. Get buffer by file name. Let me look up the docs for that so I can refer back. Get buffer by file name. Here it is. Clicked on the wrong one. I may be cut short here because I didn't get started quite on time and I have lunch plans. Yeah, alright. I have to shut down the stream temporarily. I will be right back.